All right, so I had some people asking me about some of these formulas and just rearranging formulas to find different target variables. So what I'll do is just write down the formulas here, and we'll see if we can rearrange them. So somebody asked me about, my pen is not cooperating. Somebody asked me about trying to solve this equation, h equals a over b, trying to solve that for the letter b. Sorry, for the letter a. Someone asked me about this one, m over n equals p over q, trying to solve that for the letter q. Somebody asked me about some other ones that are a little trickier, so I'll just write one more down for now. We're going to try to solve this one for the letter b. All right, so to get a by itself on this, remember the goal is a. To get a by itself, all you have to do is get rid of the fraction. Multiply both sides by b, we have bh is equal to a. Anytime you got fractions, you can just, whoa, why did it do that? Anytime you have fractions, you can just multiply to cancel out the fraction. Sorry, I'm having some technical difficulties with the pen. Okay. On the second problem, I'm supposed to get q by itself. So I'm going to multiply by both denominators. M times q equals p times n. I'm just multiplying, cross-multiplying p times n. And then if I want to get q by itself, I can just divide both sides by m. And I have my answer, q equals pn divided by m. Okay. And then on the third one that I wrote, I was supposed to find the letter b by itself. So I'm going to multiply both sides by d squared first. So I have d squared h over g equals kb. And then I'll divide both sides by b to get k by itself. D squared h over gk equals b. All right. And the other two that were asked about had two separate fractions with adding and subtracting involved. And so in those problems, you're going to want to have a common denominator. So if we look at a problem like this, 1 over m plus 1 over n equals 1 over t. We want to solve it for t by itself. What I'm going to do is make a common denominator on the left-hand side by multiplying both of those fractions by n and multiplying both top and bottom of that fraction by m. Now both of those denominators are nm, so I can add the tops. N plus m divided by nm is equal to 1 over t. Now just like on the second example, I can cross multiply. T times this numerator, n plus m, equals 1 times n times m. And then to get t by itself, I just divide both sides by n plus m. So I have n times n on top, n plus m on the bottom. There's just one other one that was asked about, which was taking this equation, m equals f l minus x over x, and trying to solve this for L. Okay, first let's get rid of the fraction by multiplying by x. Then let's divide by f, mx over f. The other option is, if you want, you could distribute f right there. That equals L minus x. Come on, don't fail me now, marker. There we go. And then I want L by itself, so I add x. X plus m, come on, x over f. So that is a correct answer. If you want to make it match the answers that they have written down, you can make a common denominator by turning x into x over 1, and you multiply top and bottom by f over f, just like I did on the last problem. So that tells me that L is actually equal to fx plus mx over f. One last thing you can do is notice that both terms on the top have an x in common. So you can factor that out, and that would be f plus m over f. Come on, and that's what L equals. So there you go. Let me know if you have any questions. Happy to help explain.